On to my presentation. So we're going to talk about Pico tracking balloons, and I know you guys will have questions, so if you want to interrupt me, go ahead. I'm fine with that. Okay, so what are Pico tracking balloons? We're going to talk about that tonight. What do they do and how do they work? Are they legal, and what about aircraft hitting one? I know that's a big question people always have. We'll get into that in a little bit. How big are they? How high do they go? How long do they stay up? How does the balloon get tracked? I'm going to cover all of that tonight and get the right way. Pico tracking balloons are typically made from mylar or latex. Sometimes they use two tied together to lift more weight. They're somewhere around 34 to 36 inches in diameter. The popular ones are Yokohama, Orvis. Chinese party balloons used to be popular, but most people nowadays are going with the Yokohama balloons. And then the scientific balloons, they've all worked. The balloons typically carry a payload of around 12 grams of weight, and they have a tracker with them, and I'll get into that. It's mostly WSPR, and the whole system weighs around 12 grams, so it's extremely lightweight. That includes your solar panels, wire, and string and strain relief tape. And sometimes they use LiPo batteries and super caps, but a lot of them don't, and they just let them go dark at night, and then the solar panels activate the transmitter when the sun comes up. And it also has a GPS and a temp sensor usually built into the tracker. And we're only talking 25 milliwatts of signal. There's no filtering on the transmit signal, so it's very frequency agile, and they don't worry about it, so you can pretty much go on any frequency you want with them. They have embedded Maidenhead 4-digit grid square and call sign. That's part of Whisper, and the GPS information interfaces with the WSPR on the tracker unit, and so it's able to know what grid square it's in as it travels across different countries and states. And so the object with these balloons is to successfully launch it with a payload and get it up to around 40 to 5,000 feet. And that's above the weather and in the clear. So if you can get it that high and if it can stay there, you have a good chance of it circumnavigating the globe. And it's also out of the airline traffic for the most part. So the big question is, what about the FAA? Well, the FAA states small balloons under a total weight of 6 pounds, it's not a concern. It's not going to damage an airplane or an engine if it gets ingested in one. And it's all under Federal Aviation Regulations 101 rule. This is a 6-pound rule, except where indicated you fly a payload that's under 6 pounds, you're exempt from most FIR 101 rules. I say most, but there might be some exceptions. But for the most part, it's safe to let them go, and the FAA doesn't care. It's such a small thing. So the way this works is the top leg of the HF antenna, it's attached to the bottom of the balloon with the antenna wire, and then there's a strain leaf string that follows the wire down to where the transmitter unit and solar panel array is, and then the rest of the antenna hangs straight down from that. The antenna legs, yeah, they're vertical from the balloon with the tracker and solar panels in the middle. And we're talking number 34 magnet wire for the antenna, and it's a full half-wave dipole for 20 meters, so it's 33 feet long wire on it. So a lot of people, there's always a controversy with helium versus hydrogen. Helium has gotten very expensive. It's not a renewable resource. It comes from the ground. It comes from decayed uranium and one other element from the ground, and then it comes to the surface. And now that SpaceX is in business and NASA, they're using huge amounts of helium for cooling in spacecraft. So the price is going up, and some people say, well, let's just use some party balloon helium. Problem with that is it's diluted down, and it's not as good. And the other problem with helium is it's got smaller molecules, so it has a more of a propensity to leak. So my choice is going to be hydrogen, but people have been successful with helium as well. The downside of hydrogen, it's explosive and flammable. Everybody goes right to the Hindenburg when you mention hydrogen, but if it's handled safely, it's fine. You just have to use safe practices with it. And we're talking such little pressure that it's not going to be an issue. And you can usually get hydrogen from welding supply shops.
Have more lift too.
Yeah, yes it does. So there's been a lot of successful flights using both helium and hydrogen. And then the thing to keep in mind is when you're at sea level and you fill this balloon up, there's a lot of science behind this. You're not going to fill it up to the full inflated, because as the balloon goes up in altitude, the air pressure gets less and less, and the balloon's going to expand, and then it'll just keep going to the point of where it'll explode at 100 some odd thousand feet, and that's no good. So there's science behind this, and I'm going to get into that a little bit. And then the other thing is the opposite is if you don't fill it with enough, you're not going to obtain the altitude of 45,000 feet. Then you're going to get in the clouds, and the balloon's going to collect moisture, ice up, and then the balloon's going to come down. So that's the other concern. So the idea is to build a balloon so it's at a neutral lift position. You get all your payload, or you can use weights and get it to balance just at that point. And then typically they add 7 to 8 more grams. They call it free lift. And you do that with weights also. So once you get it to that neutral point, you add another 8 grams of weight and get it to pick that up. And then that's your final filling of the balloon. And so what we want to do is we want to get that balloon to the 45,000 foot level, and we want it to stay there. So once it's stable at altitude, they call that the float level. And the idea is to get it to ride the jet streams so it can circumnavigate the globe, hopefully.
So Glenn, how do you get it to stop at 40,000 feet?
Well, it's like I said, you get it to where it'll pick up the weight of your payload, and it's not going to go up or down. It's just sitting on the table, just barely picking the weight up. And then you add 8 more grams of weight and let it pick that up on top of your payload, and that'll get you up there where you want to be.
But whatever makes it stop?
The air gets thin enough to where the given amount of hydrogen or helium in there, that's as high as the balloon's going to go. It's going to stay put and float.
I see.
So this is talking about the free lift. So prior to filling these balloons, they talk about, particularly the Yokohamas, they're a clear, I'm not sure if they're latex, I'm pretty sure they're latex. Anyway, you got to pre-stretch them, and they need to be done in a high humidity, and even though it's a 32-inch balloon, they recommend stretching them to 94 inches. And you just take a tape measure and measure it, and you slowly stretch them. You don't do it all at once, and it takes several days. So you get it all pre-stretched, and then you deflate it, and you can store it, and then when you're ready to launch it, you can fill it, and it'll be fine. But they recommend in a very high humid environment when you're stretching it. And it's also a good time to check for leaks. So it can be very tricky launching these. There's a lot to go on here. You've only got number 34 magnet wire. You got 34 feet of it. You need to deploy it so it doesn't get tangled in the weeds or the grass or the bushes, and you want your balloon to start ascending. And it doesn't necessarily ascend straight up. It might go vertical for a little bit. So you need a big, huge, wide open space. No power lines, no trees, a big open space to get this thing going. And if you launch early in the morning, this is a good time of year to launch one of these balloons right now. You don't want it to go into the clouds because, again, it'll collect moisture, freeze up, and come down. I'm on a email list. They call it Pico Balloon IO group. And there was a gentleman in England, and he did everything right. He tested it. It was great. He launched it, and he forgot to check the weather, and it went right into some weather and came down. So, but you always learn when you launch these things. And then it depends on testing and testing and testing again. I can't emphasize enough testing on the ground before you actually launch it. And again, it's a lot of luck. There's been experienced guys with these balloons, and some of them have lasted hours, some of them days, and some of them months. So it's a little bit of luck, and a lot of science. But some of these balloons, they've circumnavigated the world 7, 8 times and riding the jet streams. And while I'm talking about the jet streams, there's a phenomena here that happens. You launch your balloon, and it goes up to the North Pole, and it gets in the Arctic Circle, and it'll circle the jet stream. It's like a big toilet bowl flush, and it just circles and some of these guys have been stuck up there for weeks, and then finally they get into the other jet stream and move on. But they talk about it. It's pretty funny.
Does it take it to the Alps? Have you said
Say what now?
how long until it gets to 45,000?
Just a matter of hours. Yeah. Yeah. It's a good launch if it survives the night. But there is plenty to go wrong. Sometimes people launching the very first time, which will be me, they're not really failures, they're just learning opportunities. So you always learn from them not going right. But it is a good sign of relief if you can get it to survive the night and wake up in the morning and transmit on the whisper, and you can find your balloon that it survived the night. They do go silent during the night because it's only powered from the solar panels, and most guys are just using solar panels. There's a few with the LiPo batteries, but that's just more payload and more things to worry about. And from what I've read, the LiPo batteries, they get too cold anyway, and they don't survive. And so there's a lot of these trackers to choose from. There's real cheap ones. The two most popular ones is the QRP Labs, the U4B, which I'm going to get into detail on tonight. And Hans Sommer, he's been playing with these balloons for years. He owns QRP Labs. He lives in Turkey. He's got a lot of other great products. If you like to build things, he's got a lot of QRP projects that you can put together, and little CW rigs and some digital, I think it's called a QDX, and strictly digital, and you can put it together yourself. And his products are fairly inexpensive in the scheme of things. So his ham call is anyway. Hans Sommer's a great guy. He's an RF engineer, and so there's the U4B, and then there's a Tracheto, and I have both of them. And you got to add a Raspberry Micro Pi to the Tracheto, and then load the software from a USB stick. The U4B is all set up. All you have to do is put in your call sign and your grid square, and you're good to go. You can add more sensors. It's got unlimited capabilities. And some people actually float them in the ocean. There's other applications for them, but the U4B is, and it also has basic for programming if you want to do some customizing programming with it. And that's what the U4B looks like. And I have one here. And there, I don't know if you can see it, but there it is. I'll pass it around. You guys can. And that USB port breaks off once you're ready to launch.
That saves you a forever.
Yeah. And it's got a built-in GPS chip. That's the bottom side. There's a GPS chip there. And this is the Tracheto setup with the solar panels and the Raspberry Pi Micro attached to it. And I can't really pass it around. Well, I can pass the box around. It's not really totally set up yet, but there's the solar panels and the Trachetos in the box there. But I'll pass a solar panel around. They're very fragile, and you buy them on Amazon. They come in a 100 pack, and they're like glass. They'll break. You set them on something, or you heat them up too much, and they'll break. So, and then here's the Tracheto without the Raspberry Pi on it. It's soldered. The Pi solder's on the back side of that. And there's a micro Raspberry Pi, and it's only $5. It's more shipping from Adafruit than the cost of the unit. They're only $5. And there's a picture of it. And that perf board, that's just the standoffs in there. That's just to line it so you can solder it on correctly and keep everything straight. And I'm not sure who makes this tracker, but that's another design. And then QRP Labs also has a tracker. It's a lot more money, but it's also got APRS on it. And so a lot of people like to have the APRS because even at 40,000 feet, when it's over a populated area, it'll pick it up and start transmitting APRS. So, but it's a little more money. And that's the other thing I want to mention. Once you launch your balloon, you're never going to see your stuff again. It's a lost cause. It's gone for good. You're never going to find it. Now this is an example of Whisper weak signal propagation report. This was my radio, my K3S Elecraft at home at 5 watts with an in-fed half-wave antenna, and that's where I was getting all over the place. That was a few months back, but that was with 5 watts with Whisper. So, but that was on the ground. That was my home station, yeah, at 5 watts. So.
That was his home station.
Yeah.
Oh, yeah, not up and up.
No. And these units are only putting out 25 milliwatts, so it's real extreme low power.
But this is with 5 watts.
Yeah, this is 5. I'm just showing you that Whisper works quite well.
Is it like a digital mode?
Yeah, WSJTX has Whisper built into it. The thing about Whisper, I'll get into it a little more, but you have to have a very accurate clock because the timing of when it transmits is critical. So here we go. Whisper, it's a weak signal propagation report is what it stands for. It's a digital HF signal at very low transmit power. Most people are running 5 watts or less. If you're over 5 watts, you're defeating the whole purpose of it. There's receiving stations and transmitting stations all over the world. And then there's a network that is called whisper.org, and it collects the signals received and transmitted, puts them on a world map by band, and then they have a line where it traces your call sign on the map to who's receiving you. The transmissions are 6 hertz wide. It's at a baud rate of 1,468.48, sending 50 characters in 110.6 seconds, beginning 1 second after each even minute. It sends your station call grid square, and I think that's about it. Sorry about my slides getting cut off here. And then I can get into the U4B a lot more here. This is off of Hans Sommer's website. So it was developed from 2015 to 2022, and it was in collaboration with Dave, VE3KCL, and he's had 83 flights, probably more than that now, and he lives in Toronto, Canada. He's like the Pico balloon guru of the world, and he's done a lot of experimenting, and he had one that's gone from 2 hours to 305 days, 10 months, almost 17 laps around Earth, and had a lot of fun with them. So if there's ever any questions, you just get on the Pico IO groups and ask him, and he's more than happy to help you out. It was designed to be used, the U4B is easy to use, lightweight, low cost, and it's real simple to configure, or you can make it real complex. And then he also has a tracking site on his website for more information on it and what channels are available. So when you plug it in, you're not going to be transmitting on somebody else. So it contains a Small circuit board, as you can see. Then the micro USB port gets broken off once you're ready to go. And it's got QDOS, which is its own operating system, 32-bit ARM microcontroller, 128K disk on an EEPROM, 27 milliwatts max, and it's using an SI535-1A synthesizer chip. And then it's got a TCXO reference frequency stability. And it's incredible band coverage because you can go all the way from 2,200 to meters to 2 meters. And it comes with a built-in temp sensor so you can see your temperature when you're tracking it. And it's easy to upgrade the firmware, and you're not going to do that once you launch, but once in a while he does have upgrades. So like I say, you just plug it in and put your call sign and register the flight name and details on the website, and away you go. And it also has 19 general input-output pins, and 9 can be configured as analog, so it's got a lot of capabilities. 12C bus for connecting additional sensors, pressure, humidity, and as I said, it has basic programming language. Command line utility, telemetry over Whisper for relaying additional sensor data. It can transmit all these modes, Whisper, extended mode, and slow minute WSPR, JT9, 1, 2, 3, 5, 10, 30 minutes, JT65, Hellschreiber standard DX, and slow multi-tone FSK, and I think it does QRSS also. Yeah, there it is. So it's for that little thing, it's got a whole bunch of capability. It's impressive. And I think the whole unit costs around $70. So, so then safety, if you or anyone else gets seriously injured or worse, that's gonna really take the fun out of the whole thing. So it is important to pay attention to mass amounts of safety. We get so excited about things. We go, hey, it might be a good idea to launch from a balcony or whatever. Next thing you know, you're reaching over and now you've ruined your whole day falling off the balcony. So stay on the ground. You want to be in a large flat area, no trees, away from airports, military bases, power lines, and it's a good idea to have another balloon with you with helium, a party balloon, just one of the small ones, and let it go, and that'll give you a good idea what the wind's doing and where yours is going to go when you launch. It can go for a while horizontally in the slightest breeze that you don't even know exists. So you just can't assume it's going to go straight up. So it's good to determine what the wind's doing. I mean, ideally it'd be a non-windy day, but I've seen people launch them and talk about launching them in wind, but you want it to be a minimum. You don't want to do it on a big windy day. So just more safety stuff. As I said, don't do it from a roof or a balcony. So yeah, balancing precariously is not a good idea. Better to stay on the ground and do a bit of extra thinking to find a suitable launch site. And then if you are going to use hydrogen, just remember it's explosive and flammable, but hydrogen has greater lift, it's cheaper, it's a renewable resource, and it doesn't leak as fast. So if you decide to use it, just make sure you've done the research and know how to properly handle it, the minimum following all safety instructions in the container you get it from. Common sense. Yes, sir.
Just a quick question on altitude. How do you calculate your altitude if you don't have a pressure?
I think Whisper will tell you through the GPS. Yeah, correct. So aircraft, an oft-repeated objection to high altitude is that the danger is to aircraft. That's a question I get all the time. And so Hans Sommer said he spoke to numerous pilots, and so have I. And I actually was an aircraft mechanic for 39 years working on corporate jets for Cessna. And something that small, it's not an issue at all. They're over-engineered to take care of that kind of thing. The airliners, they actually have a cannon that shoots frozen chickens into the running engine to see what kind of damage it's going to do. And it does damage them, but they keep running. So, and that's what they're after. So just make sure it's away from an airport and better yet, away from military bases. So at least get the tracker set up so you know that it's working on the ground before it goes. And I tested my Chico on our patio with a wire just laying on top of some patio umbrellas, and Whisper was picking it up just fine. It was unbelievable at 25 milliwatts on the ground. So anyway, best to delay a launch and then come back another day. There should be plenty. Then risk of injury or life. So as I said, test, which is not really part of safety, but it's sanity. And you need to look at every possible scenario you can think of and just make sure you test everything. And don't miscalculate your gas volume. And as I explained, you want it to pick up the weight of, that's your antenna weight, your string, your tape, your solar panel array, and then you want to add another 6 to 8 grams of lift to that, and that'll put you at that 45,000 foot level. And then it's your responsibility to make sure you're within the rules of regulations of what the FAR say, which is basically if it's under 4 pounds, you can do it. And again, the U4B is a simple design. And then the brains is a STM 32F103 CBT6 microcontroller, 32-bit ARM Cortex M3 processor, 128K of program memory, 12K is used for the bootloader and 116K for the firmware. And then the speed of the controller is 72 megahertz. It's run at a much slower speed, and this is the leisurely application he has it here to reduce the current consumption. And then it's got an 8 megahertz crystal for the oscillator, and it's used to generate a 4 megahertz CPU clock during flight, or 18 megahertz when it's connected to a host PC. It's a micro USB connector, and it gets broken off before you launch, and it saves weight. It can be powered by the PC, and unless you've broken it away. So this is just more information on it. So you can use it under firmware control and a low power mode connected to the output pad. And so anyway, this is just more on it. Like I say, it's incredibly flexible little device for as small as it is. And then if you connect C1KO and C1K1 to opposite legs of a dipole antenna, the power output can be conveniently controlled by basic commands set to low or high power mode. There is no low pass filter, so that gives it the advantage of it being able to go to any band, but the disadvantage, no harmonic attenuation. But given the very low output power, it's probably not going to be a problem. If you wanted, you could probably add an external filter, but it's just more weight, and most people don't. The 22K resistor R2 and R4 provide some protection against static buildup on the antenna. The synthesizer is powered via half the dual P-channel MOSFET. T1 under control of the microcontroller via the SW synth signal. Similarly, so this is just more technical on it. I'll just go over it quickly here. So anyway, he's really done a lot of design on this to make it low power and efficient, is what this boils down to. So there's the hookups for it. That's the top side. And the GPS antenna is only about that long, and it's just a wire that's twisted, and it works. And then there's the bottom side, voltage regulator, EEPROM disk storage, GPS module, and then your GPIO output pins, or input and output. Okay, so now we go into solar panels. There's a variety of options to choose from. And the big thing is you got to consider the angle of the sun. Here in the northern hemisphere, our sun angle's not high. It's kind of on the low side. So the tracker's going to go to sleep at night and not transmit. Wakes up early once the sunlight and the solar panels get energized. The northern hemisphere has a low sun angle. One solution, and this is what the guy in Toronto ended up doing, is he took packages that you buy at the grocery store that your meat come in, cleaned them, and then he made a pyramid design with solar panels. And that way, no matter what the angle of the sun was, it would hit some solar panels. And he put isolation diodes in, so whatever array was getting energized, it would power the tracker up with that array. And worked really well for him. This is the Chico. This is what I showed you in that box that I passed around. That's how they're soldered together. They're two circuit board strips, one on top and one on the bottom, and the panels get sandwiched in between them. And then the tracker gets soldered onto those three tabs in the middle. And you should have 3 volts or slightly more. And there's a big difference from one solar panel to the other. They're cheap. Like I say, you get them in a box of 100, so you got to sort through them and find the best ones to use.
You measure the voltage on it?
I do. So, and you just use the plated holes as test points to go from panel to panel, which are, he's got the red and the black lines to show you the half volt, add up to 1 volt. There's a tracker, and there's the meat package, and the wire's all wound up on some styrofoam. You can use cardboard or whatever, but that's how you get it ready to deploy without it getting tangled in the weeds. And it usually takes 2 people. And a lot of people go, "Oh, can I come watch you launch?" And the answer is no, because 2 people, you don't want a lot of people around watching what you're doing, because it just adds more stress to getting it launched. You can tell them to look on the website and you'll see it. You can track it. And then I talked about the APRS. So in conclusion, there's a lot of luck and a lot of science behind this. NOAA actually has a site that predicts the jet stream current condition, and it helps with tracking prediction. And like I said earlier, that some of these balloons are circling numerous times before moving on in the Arctic Circle. And some of them will just go silent for weeks on end, and then all of a sudden they start transmitting again. So there's a lot of stuff. And unfortunately, there are jammers in the Middle East and Russia. And some of these people, it's hard to know exactly what's happened to their trackers, but they think they've been jammed so hard that it blows up the transmitter. So, and believe it or not, with our technology today, these balloons can get tracked by radar. They can see them. So, but despite all this, there's been a lot of successful flights, and it's kind of fun. So I'd be happy if mine made it to the East Coast with my first launch, and it'd be better if it went across the frosting on the cake if it goes across the Atlantic. Here's one that's filled with gas ready to launch. You can see that it's not nearly fully inflated. You can see that it's picking the weight up. And there's...
That was a Mylar balloon?
Yeah.
So that one, you don't stretch that.
No, I don't believe so. And then there's the solar panel array getting ready to get deployed. And there he is with his balloon getting ready to launch it. And there it is. So you can see how deflated it looks. And it'll get fully inflated as it goes up. And that's
How big are the balloons?
they're about 34 inches in diameter.
when they're all inflated?
Yeah,
Fully
fully inflated, yeah. And there's the balloon, he just let it go. And he's hoping for the best. So there's a whole bunch more on the internet about this, and if you're really interested in it, look up Pico Balloon IO groups, and it's a list, and you can always, people report in what's going on and what they're having trouble with and what they like. Yes?
These circuit boards, they resistant to water at all, or once you get past the cloud, it's moisture.
They don't seem to be. They seem to dry out pretty quickly from what I see on the IO groups, and that it's not a concern. So you have to keep in mind, once you get to 40,000 feet, you're looking at minus 40, minus 50 degrees, and all the water's already frozen up there, so you're not going to get moisture on them. Yes? Sure.
How long have you been working on this flight? And you have, just curious how you actually put the hydrogen in the balloon, how you get it, welding shop?
You use a regulator like you do on a welding torch, so it brings the pressure way down to 3 or 4 pounds, and then you fill it up, and you got to keep filling it, and then checking it, and then just as soon as it's, and you might have to, or you might overfill it, so then you have to let some out, but you want to get that neutral point right there, and then you want to add your 8 grams more of weight and get it to fully pick that up, and you're there.
So how do you do that? Put in the balloon, the latex balloon, without it just pushing right back out, and you might add a little bit, check it, and add.
Yeah, you can go to the hardware store, and they usually get like fish aquarium tubing, and they jam it all the way up into the balloon, and then they do it that way, and then they tape off at the neck.
And all those stuff fully inflated when it's on the ground, right? It don't-
No.
It fills up when it gets up high.
Exactly. Yeah. Yeah. It looks like it's like a quarter full on the ground.
So
So
you get the hydrogen in a big tank, or a little tank. It doesn't seem like-
no, it's not going to be a little tank like that. The welding supply, it's probably like, are you familiar with acetylene oxygen welding? It's probably like an acetylene tank full. You can rent them. I've already checked the JB welding supply here in Chico, and they have it available. They'll rent you a tank. I think you're responsible for putting your own regulator on and go from there. So,
So how long have you been working on this?
probably 4 or 5 months now. I'm still collecting things for it. So, and I've been doing a lot of reading and research on it. So I'm getting close. It'll be next month sometime we'll launch one.
Will y'all come out and watch?
Any other questions?
What frequencies are you transmitting?
I'm going to be on 14 megahertz on the whisper frequencies.
Or what?
I think it's 14.1 something, 116, 100, somewhere in there. There.
This the Whisper network is kind of like the reverse Beacon network.
It's similar, but it's better because it's digital and it's weak signal, whereas the reverse network is full power or 100-watt power. It's similar, but it's different because Whisper.
Go to a website and look and see where you're.
Yes, you can go to whisper.org, and there's a Google map of you put in your call sign or whoever call sign you want, and you can see what's going on.
But I mean, for the balloon, will the balloon have a special call sign?
It'll be my call sign -1. So
So is that how you'll track it, by
Yeah.
going to this website?
Yes.
And seeing where it is?
Yeah. Correct.
Where it's been picked up?
And QRP Labs also has a website to track with. So yeah.
So maybe this is a stupid question, but if you're going to be transmitting like on 20 meters, it sounds like, right?
Yeah.
So the balloon is way up there, and it's getting these reports from where it's being picked up. How do you know where the balloon actually is, though?
Well, there's a Google map that shows you exactly where, because
Oh, really?
it's giving the grid square of where it's at. So yeah, if you go to Whisper, I think it's whisper.org, you'll find the map there, and you just have to go through it. You can sign up for it; it's free, and you just put your call sign in, and then you can use it. So
The tracker has a GPS on it, right?
yes,
So it
there's a
knows
chip.
exactly where it is.
Yeah,
Yeah.
yeah.
How many of these things are up there at any given
I would say I know there's availability for 600 channels, and I don't even think a quarter of them are full right now. So it's getting more and more popular, and a lot of clubs are interested in doing one, and schools. So it's a great science project for somebody.
That's good. Good 100 of them up there.
Oh yeah, yeah, yeah. But they're not all successful either. So
But you just have one shot at it when you go down for the launch, like if it got tangled in something and ruined, you have a second one you could
I
try
do.
that same day?
No, not the same day. I'd have to go get another. You have to go get another balloon, and yeah, no, you're done.
How long after a balloon was silent?
I don't have the answer to that question. You just have to. There's a website you can go to, and it'll show all the free channels. They have them in colors. Like I think yellow means that it's under test and it's pending. But if it's clear and there's nothing there, then it's available. And that's the beauty of this, having all this being frequency agile, is it's controlled by software of what you're transmitting. So once you put the channel in, then it tells the software what frequency to be on. Anything else?
How much is the whole payload?
12. I'm trying to go. I'm shooting for 12 grams or less. Not much.
Payload's 12 grams.
That's the whole thing. 12 grams. Oh, the balloon weight, they don't count it. So I'd say the whole thing's probably, it's under half a pound. All right. Well, thank you very much.